okay, in the switch case, then these are the APIs it is hooked, versus version 3, 4, 5, 6, it is actually 8153 init. So in this case we can see clearly in the box they mentioned it is version 3.0. So in that case it is R8153, and hopefully I think that is the reason it is showing as 8153A, because this is the version 3 of that 8152 driver. So I am not really sure that why they have this confused nomenclature 8152 and 8153. Maybe that the 52 or the 2 stands for the version, I am not sure, something like that. So as you see, it is a bit not too old, not too new. It is 2020 stuff. Okay. So as you see, 8152 enable this API is linked to this FOPS of enable callback, versus here for this 3, 4, 5, 6 versions it is 8153 enable. So this specific board, or I mean specific chip of this specific hardware, we should refer this source code. Okay, so we go here and we do a code walk of that function. So this is the function. As you see, it is doing something, and it is initializing actually. Again, I don't want to go deeper because I am even not aware of what is the whole thing is actually. So this is calling this internal API. So let's just click this, and you can just do this. See, many beginners have this fundamental problem. What they try to do is they literally try to understand what every line is doing. This is a very bad approach of doing a code walk, and as I say always, it is always easy to do a code by yourself rather than reading someone's code. And if you read someone's code, don't do this mistake of trying to understand every line what it is doing and try to grasp what it is happening. It's a very, very bad approach. Okay, you should always do a very casual code walk. Just see that roughly which APIs, how it is connected. Okay, once you get that know-how, this takes of a duration of 2 days, a couple of days to almost a week or couple of weeks as well, depending on the complexity. If it is more complex, there is no documentation, then take your time, take around a week, and just try to map this and write it on a paper. Okay, in a sort of tree like hierarchy. Okay, this is the API, this is where it comes, something like that. Say for instance, you have this init is there. Where is that? Yeah, init is there. You can take a paper, something like this. Let's take this itself as example, because we ignore the other one, that is not the version. So you take something like this of some of these options. Okay, so take some sort of a paper. As you see here, as we go down, it is also having other versions also, 8153B, but here if you see, it shows 8153a-3, which means it is not the variant B. So hence maybe the reason they printed as version 3. Okay, could be actually. So it is not that, but again I am not sure what is this V2 is. So anyway, it is not B for sure, it is 8153A. Okay, and so we stick to this. It is not this at all. Okay, it's not version 9. So what you can do is, you can take a paper and you can just put something like this, and you can just scribble like this is the init and this is the API, it is responsible for this init, and then this is there, and then you can further draw your hierarchical chart. So you put this, and if you go to that enable, if you have this enable, as you see, it is calling this below API. So this can be an API which is common for all the variants, and some variants have some inits, so you have a specific enable API. So you have some kind of structure like this. So rtl enable, so end of the day it is calling this API, and you see that whether 8152 is also calling this wrapper, that is a wrapper for this rtl enable. So something like this. So let's click this rtl enable, and we see all its references. Okay, and here it is getting called for 8153, which we already saw. Go back, and here you check in this line where it is getting called for 8152 also. So which means it is just a top one is a wrapper, and below it is calling, no matter which version you use, it is calling this RTL enable. So this way you try to understand what it is, overall thing is happening. So you need to map out this sort of API flow. So even this is calling this API. So take a fresh sheet of paper, specific, say we take one API and try to map out its whole thing, and this way you can do a code walk. And as I say, code walk is the most important part of your career as a developer, not writing code. Unfortunately, you are not thought about this in your college days, and they always tell you to write some program, write something, do something. It's not that. Actually, you need to first have the skills of understanding somebody's code. Hence the reason when I conduct interviews, always I give them a system connected to an internet. I give a specific a small project or problem or something, and ask them to cut, copy, paste, do whatever you want from internet and try to modify and try to make me a small solution in that given time. I generally don't give time, something you finish like half an hour or something, you sit how much longer you want, perhaps whole day, and try to get it done. So this is my simple coding round interviews which I conduct, and I no longer ask whatsoever questions about pointers and stuff. That's not the intent actually. So hence I'm saying, try to get the skills, do this sort of a map. Okay, so this looks like is the actual important API. So what we do is, we do a very quick code walk of this API as well. Okay. Yeah, so we are in this generic API RTL enable, and it has this generic context as for r8152, and you can see there it is doing something like packet filter, etc., etc., right? But I'm really not sure what it is, the whole this thing is. And moreover, an interesting thing is, since maybe perhaps this is an USB Ethernet driver, this looks far different from general NICA drivers which I always see, which is PCIe based or something like that. This is lot different than that. Okay. Again, I'm not an expert in USB, so again I want to put that disclaimer. So I'm really not an expert in USB stuff, and I'm okay with network drivers when it comes to regular PCIe network cards. Okay, not this. So that is the thing sorted out. We just check this disable part, and we see if there is any sort of wrapper API for this as well. Okay, so disable, again you have this RTL disable, and let's just check this API, and you see there it is doing lot of free up, and finally it is freeing up that resource, and it is also doing this NIC reset and stuff. So we try doing one thing is, we try doing an RM mode, and we see what it shows, the debug prints. Okay, so we do this yeah, so sudo rm mode 8152 r8152. Yep, and you can see deregistering interface driver r8152 stop submitting in interrupt or something it is showing. So we see if anything else is put over here. It's not here, maybe they must have done somewhere. Submitting, yeah, stop submitting interrupt. As you see here, this debug print is somewhat captured here, and this is an interrupt callback actually. So you can see there. Okay, which is why I'm saying always I get emails saying that how do I debug this, how do I do that. The best way you debug is just to do a prints, and if you get something like this, just compile your own module or whole kernel, and then start inserting prints. It's more than enough for you to learn. Why do you need to go with any advanced debugging tool? Simple print always works, provided you have enough patience and you are ready to do that extra effort by compiling your own sources, and then put fine-tuned prints wherever it is needed. Okay, so yeah, this is matching, and it shows status is -108, and this is the status, and we see this is the status and URB status, something like that, and there is this again a data structure. I'm not sure, it is a part of this USB.h, and you can see there, and hopefully it is URB status, and you can see there is an int of status, and we see if there is any hash define or enumerated data type for that status, the value 108. So let's try that 108 and we see if anything matches. Okay, if it is enumerated, of course we can't find that number, or otherwise if it is hash defined, possibly we can find it out. Yeah, not sure. This is 108 minus 108, not sure, somewhere it will be defined and we need to find out. You can find out if you have enough time. Okay, so that's what is the status. Not sure what the status mean. Okay, if you are a USB driver developer, perhaps you can mention in the comments. Okay, so something, even I'm not sure what the URB meant. Okay, so anyway, let's quickly ignore that, and we try doing an insmod and we see if it is able to do an insmod and able to get that interface up. See, if you do here if config, you can see the interface is not up, and now what we do is ls sudo insmod r8152.ko, I'm sorry, insmod. Yeah, it is done, and you can see there it is registered and it is showing the same debug output like earlier. Okay, carrier is on, which means it is connected to an Ethernet cable, and let me do an if config, and you can see there it is again up and working. Okay, so one thing I can do is I can disconnect this Ethernet cable and we see if any debug prints it gets. So one more thing optionally you can try is you can go to sysfs sysclass net. You can go here and you can go to this driver or port, corresponding port, and you can do a cat of this carrier up down count. It shows 1, and you can also see the carrier status. Okay, you can do this cat carrier, it shows it is up, which means the cable is connected. Okay, so I can pull this cable out. Yeah, I just disconnected this Ethernet cable, and we do this carrier, it shows 0, up down count, it shows still 1. Okay, it is only up count. Okay, let me try this carrier down count. Yeah, carrier down count, it shows 2. Okay, so we later again check by reinserting if the up count increments. Okay, this I never tried, but I know about this carrier. And we go back to this log messages, and you can see in the log messages it shows the carrier is off. Okay, so again we see that if it is printed, if the debug is programmed here, or it is coming from other dependent data structures or some subsystems. Okay, some sort of third party services or something. Okay, so let's just try this carrier. Net if carrier is okay, when link is down, driver would cancel all bulk, so this avoid resubmitting bulk. Okay, so you can see some API, and we see something, it is set carrier, if it is this, if it is this, if it is this, carrier on. So you can see that this is the API which is actually doing that dump in the log messages. Okay, so yeah, so it is not a part of any other third party subsystem or APIs. It is a part of the driver specific logic itself. You can see this is the API. Possibly this is common for all variants. So again, now with this thing known, if you want to add something, if you want to investigate something, you can add here, do some extra prints, and then try to learn. This is how you should learn doing kernel programming. Okay, first learn what the existing source is, then you can think about or dream about adding your own stuff. Okay, 99% what I always see people fail to understand is kernel doesn't need any new source code. Okay, as I said in couple of videos back, in my recent video, there are very few exceptions. This what is the purpose of kernel development, and I shown an example of the firewall modules which we did for SMOD, and there are very few exceptions. Although there is IP tables extensively, people and lot of companies use IP tables, I can't use that because I need extensive logs out of kernel. So IP tables doesn't have that. So I felt, let me completely frame my own firewall, and moreover IP tables is not only about firewall. So I have done something like that. So 90% of the times you never need to do any new features or new stuff in kernel at all actually. So if you are a beginner, it doesn't happen. Kernel has everything. So most of the times you have to put lot of effort in terms of understanding what the existing source of kernel is. Sometimes you may get a job to do maintenance and bug fixing. Sometimes you may get a job to improve some feature or do some porting and stuff. Hence you need to come to this approach, and later you can think making your own stuff. Okay, so that's what. Hence you can see this is also matching here, so that is there. And let me reconnect and see what it shows. Okay, let me just quickly reconnect this. Oops. Yeah, it shows just carrier on, and it should turn on the interface as well. Now let me do that here. If config, yeah, you can see interface is up, and you can see up count, which currently it shows us 2. So this gives an idea that how many times it is down and up, which is quite handy, because I do have such counters in my SD-WAN infrastructure, which I architected, but I do in a different way completely. Whenever it is truly disconnected, especially the WAN ports, I check true internet connectivity and decide that the network is down or up. Okay, although it may be connected to a NIC card. Imagine you have an broadband router, and if it is connected to your broadband service provider, and if it is locally up but their network is down somewhere, so what happens is it still shows the status is up, and you may have a valid IP address, WAN IP address and stuff, but you may not have internet connectivity. So still it is treated as disconnected. So what I generally do is I check the true connectivity and conclude whether it is link is up or down, not just with parameters like this. Okay, either this Ethernet disconnect, or lack of IP address after you disconnect this Ethernet cable, or issue with last mile connectivity, something like that. So I'll check true internet connectivity and conclude whether it is up. So in that case, maybe in tandem with that, this may be useful, but anyway, hope you got the point. So other than that, what else is there? The intent is to not revisit every API, and try to just capture its essence. Okay, that's the whole intent of this video. So we again go back to that switch case statement which we found earlier. So it is somewhere, yeah, it is here. Yes, disable up and down. So we can quickly go through this up. It is interesting. We open this up. So 8153B up, and here it does few things, and looks like there is no common API much. Okay, so it is not like that the other one, which is enable and disable. Okay, you don't have something like that. Okay, so it is doing something, and it is finally bringing the port up. TP false, USB speed super, and let's see what is the data structure for this. This is an enumerated data type, and you can see here it has all the specifications. USB speed super, USB speed super plus, which is 3.1. okay, and in this case it is 3.0. It is USB 3.0, 3.0 or 3.0. Okay, I generally call once it is after the dot, I call it as O. Doesn't mean it is O, it is meant 0. Okay, it is USB 3.0. So this is speed super, which is what is defined here. Okay, so which is correct, and this is what, and I am also skeptical, and I want to check what is the spec for this 8152 up, 8152 up. Yeah, this one is 8153. Let's quickly check that. 8153 up. So here it has a spec of USB. Yeah, there is another API. Let's quickly open and check. This does not have. And what about this one, USB up 8152 test bit something, and even this does not have. I want to check also this USB speed, at what instances it has been defined, how many times it has been defined. Okay, so this is there in 9338 line number. Okay, here, yeah, here they have hard coded here below USB dev something, and apart from that it is not done over here this way. Yeah, I'm sorry, it is not hard coded, it is checking it. If it is less, then do something, and if it is more, do something. And where else it is used? 9733, again it is doing a check here, which is a part of a probe API. Yeah, which is a part of probe API. Once all the init is over, it is doing something over here. And USB speed, apart from that it is USB speed option something, this runtime enable, this is for 8153B, 8156, USB speed full and low, exit OOB something. So USB speed full and low, which is yeah, full is 1.1 and low is 1.1. Okay, you can see here it is USB 1.1, and that's what they are checking against, if it is connected to a low speed USB port, something like that. Yeah, so I just started exploring this out of curiosity, but I may do further some more time. This looks very interesting, and I know a friend who knows a bit of USB driver stuff, and I may check with him if I have any questions, and perhaps we can have one more follow-up session if I find anything interesting. So apart from that, you can have this you can find this hardware fee config. Again, I'm not sure what specifically they may do here. It's doing apply firmware, enable something, set bit fee reset. What is this? Not sure, because this may be specific to this device. Fee reset, which is a part of this rtl8152 flags. Okay, so 0 1 2 3 4 5. Okay, value 5 is the reset, something like that. Apart from that, what else is there? Set E, get E. I'm not sure about this unload stuff again. See, one thing you should notice is unlike PCIe drivers, PCIe you just connect it and it is not hot pluggable. Okay, you don't find some of these APIs which we find with USB Ethernet, unlike what you find in PCI card. There you just plug it and then it remains as long as the system is powered on. Of course, you have the option of RM mode and ins mode, but you don't have any options of hot pluggable disconnects and stuff. But here it is not the case. Hence, this looks a bit alien to me, because I never much explored any USB drivers, or nor I am an expert of any USB specs either. So this way it is completely I am alien to this. So perhaps I may inquire. If I find anything interesting, I can do a follow-up, or I may even include that person to explain some bits and pieces of this source code if he finds anything interesting to share. Okay, unload. Yeah, power cut enable, something like that. Let's do one thing. This time what I do is I'll unplug that whole USB port, I mean USB adapter, and see what happens, not just a cable. Okay. Yeah, see, you can see I just pulled this cable out, and let me do an if config. See, I'm just the reason I'm doing this if config is they should have those cleanup routines to uninitialize as once this event occurs. Okay, same way I will check quickly this what is that this module also. Okay, so ls mod ref8152. Yeah, the module is still there. You see there? Okay, the module is still there, and it is taking up resources, and perhaps once I reconnect, it may reinitialize, something like that. I'm not sure. So which means it is not fully, taken out. It has not done any automatic RM mode. So the module is still there and it is running, but it shows the status as USB disconnect. Okay, and device number 9. So let's try finding this print where they must be doing it. Okay, so find disconnect, USB disconnect. Oh yeah, see there, rtl8152 disconnect, and it does this, and we see where they may be possibly doing the print. So you see there, that is what is this disconnect API callback is. Okay, USB driver 8152 disconnect. Yeah, so yeah, that's all it is. Okay, so the table, let's sum it up. Table has these specs, vendor ID Realtek, and these specs. Next, the probe as that probe API as we saw earlier, and disconnect, suspend as this API. Yeah, this API, resume, suspend, restart, resume, pre-restart, post-restart, something, stuff like that. Again, I'm not sure. Let me see if I get any insight on this. Okay, so I feel let me just conclude this episode. I don't want to go any more deeper. I'm not even an expert on this. So hope you got some insight. I request, especially if you are a beginner, or even I have seen my students as well. So if you have got suddenly a job and you are a little bit not comfortable with whatever task assigned to you, because 90% of the times you need to do this code walk of your some colleagues or company source code. So have this approach, have this method. First time you do completely alien stuff, this code I never saw in the past, so a complete alien code. Take a paper, note down these things, go for a break, go for a lunch break, again come back, again note down few things, keep doing it every day, little, and by the time you have the next team meeting, you will have some flow. Eventually by 10 days or a couple of weeks, you will have some rough idea where to start and how to go about it. If it is an existing source code, you are requested to start maintaining it. So the chances are sometimes the employee may quit the company, and they may try to find a replacement, and you are the replacement. And sometimes it may be, luckily you may still have that old person and he is giving some induction here and there, but you are still requested to do this code work by yourself. Even something is quite common. So if that is the case, do a code walk, and don't expect and don't do the mistake of going every line and trying to understand. Just go with the flow and go randomly and explore the things which you feel comfortable and easy to understand. If it is anything cryptic, like I escape or like I ignore, just ignore anything which you currently don't understand. Okay, don't break your head and try to understand what exactly. See, for instance, here it shows Lenovo and TP-Link. Perhaps this is that TP-Link stuff 0601, and we see if anywhere log dump it is printing that specs. Okay, 0601 something. Okay, see here it shows TP-Link, and something it is showing some more specs and all. I'm not sure from where it is picking this driver and getting this information. So track this stuff and go back to that source code. You can see vendor ID 2357, stuff like that it is showing. So we capture that and we find if anywhere they have initialized. Okay, so it is not here, perhaps somewhere else it has some vendor metadata. So find it out and try to break down the source code and try to do this code walk every day a bit and a little bit each day, and then get all that hierarchy of APIs and data structures. Once you get that, you will get that flow, and slowly you can start getting into the project, and you will be accustomed on exploring any existing project with already source code which is done by someone else. Okay, it may be a part of mainline kernel and you are suddenly hired to do some changes on mainline kernel code and customize it as the way company wants, or it may be a kernel code as a part of the company code and you are requested to take care of some old colleagues done code which he must have left the company 6 months back, and there are no changes required, and now suddenly company insists we do some changes, or suddenly we need to do some bug fixes. Okay, it may be possible. So if that is the case, hence you got a job, then you are supposed to do that, and when you do the code walk, this is how you can approach. So hope you enjoyed this episode. If you have anything to discuss, be in touch via mail, or if you have any small queries, you can discuss in YouTube comments as well. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.